Ich kann auch ein klein bisschen Deutsch sprechen, if das möglich ist. Nein, nein, danke. All right, I'll do it in English. Welcome. I've heard people were actually falling asleep the last session, so I'll talk really loud and really soft, you know, to make it interesting for everybody. My name is Doomen. I actually hope I'm going to teach you something new, just to gauge a little bit the experience here. Who has actually built a library? Ooh, only 20, 25 people who build a framework. Oh, also not a lot. Oh, so you're actually here to learn how to build libraries. Anybody who uses inheritance? Who doesn't actually code anymore? These are the architects. So, who am I? Really shortly, I call myself the continuous improver. Why? Because I try to continuously improve myself in terms of architecture, tools, methodologies, working with people, presenting skills, everything. I've built actually a library. It's called Fluent Assertions. Maybe you've heard of that. Anybody who's using it? That's a disappointment. Well, somebody's using it, considering the number of downloads. I have a blog called continuousimprover.com, where I essentially share all these things that I learned during the day. There's probably going to be one after the session on how to improve my presentation skills. And I tweet at Doomen. It's the only thing that matters, actually. Is people actually still using Twitter? Is it not Instagram or something? Anyway, the pains of frameworks and badly designed libraries. People actually use these terms interchangeably. Libraries, frameworks. I'll try to explain the difference. Frameworks try to solve everything at the same time. Recognize anybody? Is that like something you recognize? Yeah, frameworks. Yeah, they try to solve everything at the same time. They try to provide you with generic solutions that you can use everywhere. I see no recognition here. No, okay. But they do that. They're almost like a Swiss knife. Yeah, there's a place over here if you want to join. Welcome. They hide the magic. I hate that. I mean, if you just start to work in C# or program in the .NET space, maybe a bit of magic helps you get something done, but eventually that magic is going to hit you in the face. Does anybody know how, for instance, an entity framework works? One person. Actually, it doesn't work, but yeah. No, but that's the pain with all these libraries. You have like AutoFac as a what do you call it, an inversion of control container. You have, I don't know, ASP.NET, MVC, the web forms. These all hide a lot of the magic. And I mean, the problem is, as soon as you run into a problem with that library or that framework, you basically have to figure out what happens actually under the hood. Has anybody used .peek to figure out what .NET was actually doing? Yeah, see? Sometimes you need to learn that. So it's not good to use magic. It can be useful to get things done, especially to, you know, convince your manager to show you, like, look at my magic. It's a really bad joke, I know. They're very opinionated, especially the open source libraries. They really are built from a vision that the original author had, and they force you to work in that way. And if you don't work in the way they envisioned it, they basically, bad luck, use another library, because this is the way you should work. I don't like that. What else? They restrict flexibility, obviously, because if it's really opinionated, then probably you cannot do the things you want to do with it. Usually it works for a while, because you read the README, yeah, you read the getting started of a library, you start to use it, everything is fine and dandy, and then you run in that special edge case, and then you try to figure out, how the hell do I do that? Do I need to override something? Is there a virtual member that I can hack into, which was never supposed to be doing? Anybody doing Java? In Java, okay, one person, two persons. In Java, every method is virtual by default, which means you can override anything, even stuff that wasn't designed for that. Has anybody actually designed their virtual methods to be really virtual? No, I have to say it differently. Has anybody actually designed their classes to be inherited from? Huh? Yeah, usually, yeah, okay. When does it backfire? Quite often, because people always find ways to use your library that you never envisioned or never meant to be used like that. And then shit hits the fan, especially on GitHub. You get an issue. I'm doing this and that and it's not working. Yeah, I understand, but I made it public because I forgot to make it internal, and now you're using something you're not supposed to use. No? I see people like, yeah, I've seen that before. Okay, they force dependencies on you. Who's using Newtonsoft.json in his project? Who has actually run into the problem that one library is using version 6, but there's already version 10 because the author is creating new versions? Yes, exactly. And Newtonsoft is pretty fine, although the numbers are increasing really rapidly, and I assume because there's breaking changes, they usually don't really hurt that much. Anybody used Web API 1 and 2 in the same project? Really, nobody? You guys are really lucky. And girls, sorry. Okay, breaking changes ripple through. Well, that's the consequence of that. If one library is using one version of a library, the other library is using another one, if you try to use them at the same time, it may not conflict in the beginning, but eventually it will break. You do a NuGet update, you get a new version, and suddenly it's going to introduce a new version of a library that the other one wasn't prepared for. And maybe it compiles. If you're lucky, it compiles. If you're unlucky, no. If you're lucky, it compiles and it will blow up in the face in production. I've had that. Everything compiles, but they change the semantics of the internal behavior of the library. And they cause daemon dependencies. That's even worse. So that library is using your library. There's another one. They both use the same one. And if you're worse, there's more dependencies there. And basically, you get a daemon dependency. You're using two libraries that both use another one. But they use the same one. And then you're locked. It is a diamond. You're locked. You don't want that. In fact, I would say I can summarize, and it's not something I invented. Somebody else I knew actually came up with that. Frameworks use you. I use libraries. The frameworks use you. Does it make sense? Frameworks require you to inherit from classes, and as soon as you use that, you'll be tied to it forever. I see somebody disagreeing. Love to hear his opinion afterwards. It's what? Oh, sorry. What I mean to say, so generally frameworks are components, library, NuGet packages that use you. You need to inherit from them. So essentially your entire code base is kind of, intertwinkled with that component. That's what we typically call a framework. A library is something you can use, and if you don't want to use it anymore, you can abstract it away. Try to abstract ASP.NET. Anybody tried? Try to abstract and Hibernate. Doesn't work. It simply doesn't work. Even though you can maybe abstract the interface and abstract classes, there's semantic behavior that's different. So, ways to avoid that. If this could all be open doors, is that actually an expression? I don't know. The principle is you build a package. Your package can be a NuGet package, can be just a project or a DLL that you use in your solution, but generally I'm talking about NuGet packages. The package offers a couple of classes. You can call them components. It's a bit of a definition thing, but the point is your package contains not just one magic God class, if I can still use that word these days, like a super class that does everything for you. No, it contains a couple of small things that each have a really specific purpose and can be used independently from the rest. They should be useful. Generally, they're useful, but you can use them together if you want to, but you don't have to. Then, yes, exactly as I said. Then you build convenience classes on top of that. Things that say, you know what, those little components that I created for you that you can happily use independently are quite often used together. So then you build a composition of that. You actually combine those classes in something that uses them in a certain combination. Again, they solve a common problem. That happens quite a lot. They basically provide a solution for common situations, but you can still use the underlying things independently. They also don't hide them. You need to understand the bottom 4 blocks to be able to understand what's happening up top of that. It doesn't hide it, just uses it. In a way, it's actually using composition over inheritance. That's probably a phrase you've heard before, I suppose. Anybody heard of that? Composition over, okay, that's good. At least 5 fingers. The library consumer, the one that uses your package, doesn't use inheritance. Although we love object-oriented programming, we don't use inheritance. People looking at me like, what the hell are you talking about? So if you have if you want to share code between your package and another package, it needs to be more abstract. That's a pretty abstract statement. But what it means is it should contain stuff that changes less often than the actual main package. If you depend on something that changes less often than your code is changing, then the ripple effect is kind of negated. Agreed? It takes you a bit of time to, ripple through your mind. Or use a really stable package. Has anybody taken dependency on Owen DLL, the Owen package? Again, 5 people. What are you building, guys and girls? Well, Owen is a part of the .NET framework, and that package actually hasn't changed for over 4 years. It's still 1.0. Must be an awesome library. These guys never created bugs. No, because it only contains an interface, which is almost the same as up there. So it's a stable package. It's red because it's an external package. So if your package uses something that's really stable, then it's probably fine. The ripple effect is going to be minimum. Don't use Newtonsoft.json though. Or if you have an optional dependency, let's say I'm building a library that does something with databases, and I want to support implementations using an Hibernate entity framework, maybe RavenDB, or what is the new one? CosmoDB, whatever that means. You don't take the direct dependency. What you do, you create a dependency package, something in between. Again, to prevent this thing, which you have no control on, having to ripple through here. So it means also that stuff that is not always necessary is going to be put in the dependency package. There's one more rule. Stuff that is not always used with the components in the main package should not live in the main package. If you have something called testing support, I don't know, some in-memory database abstraction thingy that you use for your component that is only used in unit tests but not used in production, although it may feel like convenient to just put it in the same library, don't. Put it in a separate library. They can be versioned independently. Make sense? Think about it a little bit. It's not something I invented by myself. There's a really good book. It's in the last slide. There's a reference to it. I actually had a library or a project that I was working on, and after I started creating this talk for a while, it's a couple of months ago, I realized that my own code doesn't actually follow this principle. So I started to hack away and extract, and eventually something that was 2 libraries turned out to be 10 or 8 different NuGet packages. Just to prove you that I'm not actually making this up, this is the one. 1, 2, 3, 4, 5, 6, 7, 8 packages. Oh, 8 packages. And they all follow this principle. Like the Owen one is to be able to build a web API endpoint on something that this library provides. But it means that my package would have a dependency on Owen. Well, which is not that bad. I just mentioned that it's really stable, but there's also the Microsoft implementation, which is not so stable. So I extracted away. Abstractions. That's a really crappy name, but I couldn't come up with something better. It just contains interfaces. Abstractions. RavenDB and event store. There's even a special one. I'll discuss that in a second. Testing. Yeah, what does it say? Helper classes to support testing. All right. Separate NuGet package. It's in the same repo, by the way, but it doesn't matter. Remember this. The next time you work on your library, your framework, or even the code inside your solution, think about these principles. Because just separating things even within your solution reduces coupling. Who loves reducing coupling in their code bases? Come on, this is not possible. Everybody should love this. Okay, it's almost like, how do you call these guys in the US? They have these people that follow the churches and anyway. Apparently it's not working for me, sorry. Anyway, so great libraries, they have a clear release strategy. If you go to the GitHub repository of an open source project, I should be able to see what is the release strategy. Is master the current version? Do they actually create a develop branch to work on future versions, then create a release branch to stabilize it? Or is it actually shipping every pull request, every change directly is a new release on GitHub, on NuGet I mean? So are they essentially using Git flow or GitHub flow? These are the two kind of ad hoc standards that people use. If a library is not using any of that, I try to stay away from it. Unless it's .NET, of course. They control their dependencies. They really think about how to reduce the pain that typical frameworks apply on you. You really want to make sure that doesn't happen. They are unopinionated. And as you can see, I'm really unopinionated about things. But this is important. Although the vision is that you like people to work in a certain way, you try to build, all these little components that they can use so that they can actually use it in different ways that you didn't envision. Creating one superclass and adding all these virtual methods they can override to change the behavior, that's a path to the dark side. Any Star Wars fans here? Because then the joke is not going to work, of course. Come on. But that's important. And you stay unopinionated by creating separate components, separate things that people can use in any way you want. It's really hard to do that correctly. Because usually what happens if you start building a library, I think at least in most of the cases, you have a monolith or something that is big, and you start to extract because you see something that can be reused or is being reused. So you extract it, and what happens is that that library is then modeled based on your usage of that library. And that's really difficult, because as soon as you do that, you're kind of saying to other people, you're supposed to use it in the exact same way. Make sense? No? No. They use dry within boundaries. Who's applying dry on this code basis? What is the rest? Just duplicating the hell out of it, or what? Well, dry is don't repeat yourself. I try not to repeat myself too often. Dry means if I have solved a certain problem in a certain way in one part of the code base, and I'm trying to solve the same problem in another part of the code base, I try to extract that, create a library, or a shared project, common, or utilities, or another crappy name, and then start to use that all over the place. In principle, this is not a bad practice. Dry is a good thing, because it reduces the chance that you have to fix the code base, have to fix the same bug in multiple places. But it's a double-edged sword. Dry can actually lead to a situation that everything is depending on everything. You remember the diamond dependency thing I just mentioned? That's because people are applying dry too dogmatic. Instead, think about what are the functional or technical boundaries of my system. Anybody practicing domain-driven design? Also, I can actually submit a whole list of proposals with stuff that's not being used here. Domain-driven design is more like a functional design methodology to try to map real-world business, the business problems and the concepts from the real domain, it's called the ubiquitous language, into your code base. And usually what you end up is with multiple models. As an example, consider an order, a product order from a web shop. An order on the web shop itself usually means something else or has different characteristics than an order that's maintained in the inventory system or an order that's handled in the financial system. Most people are kind of, motivated to create one order class which has like tons of properties and lots of behaviors because it's trying to solve all these different problems. In DDD, it's really imperative that you start to separate that. You have multiple classes with different purposes. They also live in different boundaries. And the boundary can mean anything. But the point is, don't try to apply dry outside the boundary. Because it starts really nicely. You start to, we refactor a little bit, and everybody does refactoring, I hope. Refactoring? Yes? Again, only 1/3 of the people. What are you doing there? Anyway, so you start refactoring, and at some point, everything happens only once in a code base. But what usually happens, and there you get the inheritance thing again, you extracted some nice class in your code base. You try to figure out how to make it generic enough so that it can be used everywhere. And then, there's one place that uses that super generic class of yours that you carefully designed and really proud of. You talked about it in your team, and you posted it on GitHub and blogged about it and tweeted about it, like how good it is. Then somebody wants to use it a little bit differently. But it's not possible. So what happens? You add another method to it. Or you make something virtual because you can. And obviously, during the code review, nobody noticed that. So at some point, you have a class that does all kinds of stuff, has no clear responsibility. Solid? Solid, yeah, solid, yeah, come on, solid. Okay, I'll put that on my list as well. Single responsibility principle. You end up with a class that doesn't actually know what it's supposed to do. It does all kinds of stuff. And then what happens, you have something that was carefully designed to do one thing, turns to bit, it's like it's trying to be pushed in different directions, and suddenly it's a monster. It's Frankenstein. That's the word of dry. So sometimes, even though it feels really unnatural, just duplicate that code. Just duplicate it. Accept the fact that that there's duplication there. If it's really complicated stuff that you don't want anybody to touch, and that applies to everything you guys create, obviously, put it in a separate library. But don't forget those things I just mentioned. But quite often, you don't have to actually build a library, because that code will kind of go in different directions. They go separate ways. And by allowing that, you end up with much more clearer code that only does one thing really well, instead of something that tries to do everything half-baked. Make sense, or am I rambling now? No? Okay. So, have helpful documentation. Really? Really? Anybody use an open source project that's no documentation at all? Again, only a few hands. I think you're just afraid to say it. It's important. A proper README. Instructions on how to build this project. Because if it's a great open source project, people like to fork the repo and create their own versions, or maybe provide you with pull requests. At least specify what version of Visual Studio you need, or what specific version of .NET. And if you use .NET Core, up to the 6 digits, specify exactly what version you need. That's important. Do you use a particular PowerShell version? Do you need Windows 10 or something? Or does it also run on Apples? God help me. Or Linux? It's important. What usually happens, people create an open source project, put the code on the internet, and then just say, abandon it, because I know how it's supposed to work. There's plenty of examples. I'm not just being sarcastic here. Have intention revealing unit tests. Who writes intention revealing unit tests? I don't believe you. No way. I've never seen intention revealing unit tests. Now, actually, I have some strong opinions, although I'm unopinionated. I hold my opinions really strong, but I have them loosely held, or something is the expression. Unit tests, for me, are not just like a safety net to be able to figure out if everything is still working. For me, a unit test explains or demonstrates to the consumers of my library how they are supposed to use. And obviously, I'm telling all this beautiful stuff, and none of my code base matches to any of these rules. I mean, I'm just a person. I make mistakes, but I can generally, with all my heart, say, without lying and smiling about it, that I really try to do this. Because every time a library, I don't want to analyze the code of a library, not the actual code, because most people don't use coding conventions like I do, or they don't practice clean code. Try clean code? Clean code. But I look at the tests. I try to see what does the API look like. What is the expected behavior of that API? What exceptions will it throw? In what circumstances? How does it behave in a multi-threaded environment, for instance? Does it support async await? Who loves async await? Yeah? You shouldn't. Just try to, it's awesome, but just try to debug something that uses the async await thing. You get completely lost, like stack traces from here to, I don't know. I can probably put it here all the way to the end if I print it out in A4 format. What was I saying? Oh yeah. So the unit tests should be clear and intention. They should show you the entry criteria. What's the starting situation? They should show you how the API is being invoked, and they should also show you really clearly what is the expected behavior. Use an assertion library. Little plug for Fluent Assertions, obviously. But it's important, because if you practice test-driven development, I'm not even going to ask. If you practice test-driven development, it's not about testing, it's about designing your API and making it readable, using it as documentation. Very unopinionated. They use semantic versioning. Anybody has heard of semantic versioning? Ah, not bad. 10 hands out of, what is it, 300 or something? So you can already see it a little bit on the shady or the blurred thing. It's a version number that has semantics, hence semantic versioning. In other words, you can look at the version And based on the version, determine, like, is this just a hotfix that I should probably take? Is this a couple of new features, including or excluding a couple of hotfixes? Or is this going to be painful because it's a breaking change? I can see that all from the number. So if the first number, if I go from 4.0.0 to 5.0.0, I know I'm going to be in pain. It is a breaking change. I have actually, in my library, because of this semantic versioning, I don't like to create a library that has version 25,000.3.6, so I actually think about the breaking changes. I'm fluent assertions is currently at 4.19.3, because I'm only doing hotfixes. I have basically saved up all the breaking changes that I would love to do for the last 2-3 years for version 5. And that's going to be horrible, because I change everything, because now I can. I go from 4 to 5, and everybody will know what to expect from that. Obviously, I will not support the old version, so people have to. But that's not even a joke, actually. No. if there's bugs, I will fix them, obviously. But there's no bugs there. But it's important. So it's not just a number, it's an expectation. Again, it says something about the quality and the control of your library. Do you really release in a certain way with a certain cadence? If somebody's not using semantic versioning, I'm not using it. Except, of course, .NET. Because we went from 4.5 to 4.0. Actually, it is backwards compatible. Is it? Anybody running any bugs by upgrading .NET? One? I don't believe you. Sorry? It is different? They've changed. So somebody's saying that async await has changed?
Yeah, by default in 4.7 they do it like configure await. They don't capture context anymore.
So what is being said here in .NET 4.5, if you use async await, there's a configure await method, which goes sprinkled all over your code base. If you use this stuff, they've changed the semantic behavior. But they didn't change the API, so it's backwards compatible. It's not. It's not. That's why we have .NET Core. That's again an excuse for those developers say, you know, I can't say that, screw it or whatever. We just change everything because it's a different product. We don't have to be compatible. Oh, yeah, but you can't do that. Now we have 2 libraries, .NET 4.5 something. We finally get rid of Silverlight and Windows Phone, all that stuff. And now you create something new and it's not compatible. You know, we just introduced something called .NET Standard and hope for the best. And it doesn't work. Anyway, what else? Oh yeah, don't use static or shared mutable state. In a library, don't use static. If you ever use static, I did, you should be shamed. It's the worst thing you can do. Is anybody using XUnit for unit testing? So XUnit, MS test? No unit testing? I need OneNote to take. So XUnit is one of the many unit test libraries. The thing with XUnit is it runs everything in parallel. So all your unit tests will be run in parallel by default. Just imagine if your library is using static somewhere. Everything will fall apart. Yeah, but then I just use thread static attribute on it and everything will be fine. No, it will not be, because async await, depending on what you do, might actually jump to a different thread. And then your thread static is going to blow up in your face again. Sorry. Don't use it. A shared mutable state is just a fancy name for, you know, sharing some global state within the system. Usually it's static, but it can be something else. Call context, or HTTP context.current items, or HTTP context.cache, or anything like that. They will blow up in your face. Don't use that. Semantic release notes. If I have a new library that I've been using it and I see a NuGet, hey, there's an update. I want to be able to go to GitHub and figure out what is new here. Why should I update? And what you then see is on GitHub, I'll show you something because I have internet. I didn't clear my cache, so it's always dangerous if you do that. And Hibernate GitHub, which is a favorite library. Then I go to Hibernate Core, I go to releases. Oh, wait. There's a new version, and they actually have release notes. That's nice. So now go to GitHub for XUnit. That's a website. That's not fair. github.xunit, I think it's called. Yeah, and then I can go to the releases tab, and you get this. To be fair, there's another website where they really extensively describe that. But if you look at my own library, to the releases, and I hope I actually did it correctly. See, this is what you get. I actually use little tags here, like this new, and changed, and breaking. There they are, breaking. Here, more breaking. Lots of breaking. But I also add some new stuff. See, every version, I do that. See, new, fix, new, change. That's what semantic release note means. It's just a convention how you document that. You don't have to use it, but at least please add some proper release notes. Agreed? It's something you use. You can also buy something commercially, but you need release notes. So there's a couple of tips and tools you can use. For instance, delegates. Who is still using delegates in C#? Oh wait, who's programming in C#? Finally. Visualbasic.net? Yay! I knew there's at least one person in this room that does it. Delegates, it's an awesome thing. Everybody forgot about it. It exists since .NET or C# 1. So I'm creating an interface, iEventStore, which has a subscribe method. And it takes some checkpoint and some handler and a subscription ID even. This is actually a nice func. This could also be an interface. And usually what you see, an interface has a method that takes another interface. And if you're unlucky, that interface requires later on another interface. So you create a unit test for that. And suddenly you have to create stubs of all these implementations. Or use, worse, a faking library. Fake it easy, mock-q and substitute, fakes, whatever. I love them, but I don't use them anymore. Instead, you can also do it like that. You define a method, create subscription with the same signature, and it's of type public delegate disposable. The implementation is not relevant. The point is, it's a delegate. It's like Bartesmet is doing all these C# 7 things, you know, completely burning up my brain of all the complex things. This is C# 1 in 2017. I'm actually showing you something from C# 1.0. Oh, what? Oh, crap. You got me. Yeah. That's true. Don't forget that. I'll just scratch that a little bit. So now it's gone. I'll fix that the next time you join my session. Always. I did it on purpose, just to see if you were paying attention. Oh, man. Anyway, but the delegate part is C# 1.0. The beauty is, you can define a method that takes this create description as a type, and then you can pass in another delegate, or you can pass in a method, or you can pass in a func, a nice lambda statement, or with C# 7 or 6, I always forget, a local function. They all map. You don't have to implement an interface or create a fake. You just create a simple function, a simple method, and pass that in. I use that a lot. It was almost like a Eureka feeling for me. This old stuff is still cool. It's almost retro. Simple trick. Next time you create an interface, think about that. A source-only package. Does anybody use that? A source-only package? A NuGet package that only adds a source file to your project. No? Nobody? Not a single? You've seen it, yes. They're really cool. It means you actually build a NuGet package, and I know in the back it's not readable, doesn't matter. This is called fluid caching, which is a least recently used cache, which means it will throw away the most recently used things, or keep the most recently used. But the point is, the NuGet package will not add a DLL or reference to your project, nor will impose a dependency on the people that use your package. It will just add a source file, which is perfectly okay for simple utility things. There's examples like liblog, which is a simple logging abstraction that you can use in your libraries that will detect automatically whether you use log4net or no enterprise library. Nobody's using enterprise library. Is anybody old enough to remember enterprise library? 1, 2, 3, of course. But this is like an example of a really fast, high-performance caching library, but it doesn't require you to take any DLL dependency. It's just a local source file, and you can still update it. I use it a lot. Tiny IOC. It's a small inversion of control library that doesn't actually have a DLL. It's just a bit of C# code. It's pretty simple to do. There's a convention, .sources, which is also the reason why I just showed you that. If I go back to this one, there's here, .sources. So this is a part of that big, set of components that just adds a source library, just a CS file to your project. Really neat. Easy to debug. You can change it. You can go to NuGet and update it. Highly recommend it. Merge the dependencies. If you really can't, like if you use Newtonsoft or JSON, use tools like ILMerge or preferably ILRepack, and just take the DLL, merge it into your main DLL, and nobody knows that you're even using Newtonsoft. You can just, secretly use Newtonsoft without anybody detecting that. There's a new project called the .NET IL linker, which is brand new for .NET Core. I think it's even preview yet, which will try to do the same thing. It will try to even merge the entire .NET framework in your library, which is great because your library will be 1 megabyte, and then you have like 100 megabytes of .NET, all in a single DLL. Now, I'm making fun of it, but it's really useful. I do it a lot, especially with complicated systems where you build lots of libraries. You just merge all the dependencies, and the consumer of your package doesn't even see that as a dependency. It's a perfectly clean NuGet packages without any dependency. And it uses Entity Framework, AutoVac, Web API, I don't know, the whole world. It will be a freaking big library though. Again, nice example. .NET Standard. Who is already using .NET Standard? Yes, of course. Only a few people. .NET Standard is kind of a good idea. It basically means, like if I look at my own library, Fluent Assertions, I had a version for Silverlight, Windows Phone, Windows RT, .NET 4.0, .NET 4.5. Then we had the new .NET, previously known, basically what now is .NET Core, .NET Core itself. So I have basically like 6 different versions, and I use all kinds of smart stuff like portable class libraries to be able to reuse as much code, share projects, to compile multiple C# files into multiple things. Now, you can actually create one project that supports a lot of different platforms. In one step, you just say it's a .NET Standard version library, and based on the version, it supports different versions of the platforms, like .NET Standard 1.3 is supported by .NET Core, .NET Framework 4.6, etc. But you can even do cross-compile these days. So I have now one library that cross-compiles to .NET Standard 1.3, 1.6, 2.0, and .NET 4.5 for the old people. All works. It's really cool stuff. Again, don't have to memorize it. The slides are already online. I use Git version. Git version is a nice tool that will actually allow you to generate a semantically correct version based on your release strategy. So if you have a master branch and you run the Git version tool, it's a NuGet package, or you can also get it as a chocolate file, it will generate, for instance, a version number based on the latest tag in GitHub, or Git basically. So if you have a tag on Git called 2.0.0, you run Git version, it will emit 2.0.0, and you can use that to automatically update your assembly info files, pass that into your NuGet.pack. But if you're on the release branch, it kind of assumes you're following Git flow, and the release branch means you're actually going to stabilize. So it will automatically add tags like .rc1. And as soon as you tag it as rc1, it will automatically number it as rc2. And if you're working on the develop branch, which is also a convention for Git flow, it will be called unstable. And some projects never leave that phase, but anyway. But it's a really neat tool. If you're not using it, please do, because it's awesome, even for your normal projects. Even if you're not building libraries, never have to touch your assembly info files by hand. Just set a tag on your project in GitHub or Bitbucket or Visual Studio Online. People using Visual Studio Online? Oh, just 10 hands, that says something. GitHub. And the rest is not coding, I forgot about that, sorry. But use it, it's really cool stuff. An example, well, that liquid projection library, you don't have to understand what it means, but it has an app. Oh, what is that? Oh, that's actually, I'm going to skip that actually. We don't have time for that. So it has an abstractions package which only contains some interfaces and simple data objects. That package hasn't changed for over a year. Again, following the depend on more abstract packages. It has the main library, which consists of all kinds of little components that are pretty useful if you're building systems that nobody's building, like me. It has nice convenient classes that will combine those little components in an often used scenario. It doesn't try to hide the package. The consumer uses it. Then there's the version that actually uses some kind of event sourcing library, which is also open source. So it doesn't depend on it. There's another one for testing. As I said, testing is not something everybody needs in production, but may need it when creating unit tests, so I put that in a separate package. There's a really ugly dependency called an Hibernate that, new versions just break stuff and you have no control of that. It's an awesome thing, but I put it red because it's unstable. It is unstable. So I put a dependency package in between. And there's another one, RavenBee, which is equally unstable with a dependency package like that. So people can use this only. They can use even only, the little boxes at the bottom. They can use all the other stuff. Of course, if they use the main library, they get the abstractions library, NuGet package, because it's important. But it doesn't change. Hasn't changed since the beginning. And they can use all the other stuff if they need it, just to reduce the number of dependencies. And you can see the errors all flow in the direction of the dependency. So the library itself, you don't need to use that stuff. You're not forced to use it. Wasn't like that. I had to refactor it. Which brings me into the last 3 minutes of something that I'm pretty sure everybody already knew. But if there's any questions, you can ask them right now, or come to me and bother me with questions after the session. I'll be around. I'll be on Twitter. Slides are already on SlideShare. You can download on them. Thank you very much for your attention. You can get some slides, some resources here. Don't copy. Just look on slides here. It's there. Don't make a picture of it. And if you have any questions, then let me know. Thank you for your time, and thank you for being here.